I actually joined Turbo back in 2014 when we were just a small little startup in Boston with a big idea, which was how do we allow software to automatically make resourcing decisions to control for both performance and cost at the same time. Now, it was a very ambitious idea back then, but I think it's as relevant as ever today, and it's exactly what FinOps teams that we talk to are looking for. How do we get the insights that we need to drive action? How can we rely on trustworthy automation? And how can we ultimately unlock measurable business value in the form of savings that finance is asking for? And those three things are exactly what we're going to discuss today. So let's get right into it. So I always like to start with this slide because I think, well, two things. One, it's really hard to put something up on a screen in a room this size and have pretty much everybody agree with it, but I think we could probably all agree that quite simply, IT's job is just delivering applications that run the business, right? Maintaining, making sure that those applications are up and running and that we're doing so in the most cost-efficient way. But at the same time, this is a similar, I would argue, probably the same goal that IT's always had. And despite the rapid evolution in technology, right, from traditional on-premise environments to hyper-converged, public cloud, containers, PaaS, AI, you name it, the number one goal still remains the same. And I would argue with all of the advancements in technology, that goal has actually gotten significantly harder over time, right? Now, these key challenges are ones that I'm going to focus on with you today. And I would argue that these 6 challenges are ones that IBM Turbonomic is very, very well positioned to help our practitioners overcome. Now, I think about these challenges as needing to be solved in kind of a chronological order. So what do I mean by that? Let's take the one right at the top there in the middle, assuring application performance, or rather overcoming performance issues. We can't do that if we're not able to prevent the bottlenecks that lead to those overutilization levels, right? If we can't stop something from becoming overutilized, well, we're not able to actually assure the performance of that application, right? It's a prerequisite. And then taking it one step further, if we want to capitalize on savings, right? If we want to hit our cloud cost cutting targets, we have to assure performance first, right? I don't think anybody in this room would be willing to downsize their applications to save a little bit of money if it means it breaks the application, right? So taking it one step further, once we've found those over-provisioned resources, that waste, well, now we need something by which we can actually automate the implementation of those decisions. We're not going to sit there and manually execute actions, 10,000 at a time all day long. And only once we have an automated strategy can we get away from some of those manual IT operations and complexity, and then ultimately leading to faster application deployment times and time back in the form of wasted time saved, right? So that's kind of how I like to think about this. Simply put, it starts with risk prevention. Once we can prevent risk, now we can truly assure performance. And only once performance is assured can we actually unlock cloud savings. So that's kind of the flow of how today's presentation is going to go. Now, let me address the challenge as kind of we define it, application resource management, or ARM for short. Now, for anyone who's ever taken an Econ 101 class, you'll probably remember this. A market equilibrium is a place where supply meets demand and price stays consistent, right? Price stays constant. We also kind of think of that as elasticity as well, right? We can only unlock elasticity when we've matched supply and demand in real time. Now, it seems simple, but it's actually an incredibly difficult concept to do, especially if you're relying on a traditional manual threshold-based alerting approach. So what I want to talk about for a second here is this concept of the desired state. So the desired state is effectively where Turbonomic is trying to keep your hybrid multi-cloud at all times. And we define that place as a place where we are within acceptable levels of quality of service at the application side, but we're doing so with maximum efficient utilization, right? So if you look at this chart here, you can see as utilization increases, delay starts to increase exponentially. What do I mean by that? You go from 50 to 60% utilized, you're probably not seeing much delay from that uptick in utilization. You go from 85 to 95% utilized, you're probably seeing significant delay. So really, we need to operate in this very small zone where we have maximum utilization, but we're still, again, meeting our quality of service targets. It sounds simple, but it's actually really, really complicated to do. Now, in order to do this, a solution has to meet certain criteria. One, it has to be hybrid multi-cloud aware, right? We can't optimize what we can't see. We have to be also application aware. we can't just be making infrastructure level decisions without truly understanding the application, right? If you've ever managed a Java application, a JVM or SQL database, you know you need to understand how memory is managed at the application before you actually right-size the underlying infrastructure, right? And I highlighted the word prevent here because that's really where it all starts. Remember, prevent risk, performance, savings. If we can't prevent risk, we can't do any of this. And we have to be able to generate and execute decisions in real time, right? If we're relying on a spreadsheet of actions that we're queuing up and we're trying to get some application teams to take those decisions next week, next month, may not even be relevant anymore. And we have to be able to automate because we can't truly be preventative unless we have trustworthy automation. Now, and the GIF is not going, interesting. Okay, let's see. This was a GIF that was basically discussing this concept of an n-dimensional state where we have metrics that are being utilized in real time to kind of satisfy that elasticity equation that I showed you on the last chart. So let me just move ahead here for one that is working. So when I talk about an n-dimensional state, what I mean by that is think about your environment. Your environment can be in any state at any moment in time, right? There are an infinite number of combinations. Now, if you think about managing two metrics, let's just start with CPU and memory in this case. We don't care about just CPU. We don't care about just memory. We care about the place where both CPU and memory is managed in harmony, meaning we're not going to right-size an application due to a spike in memory and then put it out of whack for CPU and vice versa, right? So this is a very simple example of just two metrics. In order to show, and this one's not going either, interesting, okay. Let me move ahead a little bit to the final one that I think might kind of put it all together here. So what I did have as GIFs that were, where they were working, was kind of this concept of how do we get infinitely more complex as we add more dimensions into our n-dimensional state, right? So if we manage for just CPU, it's really easy. We manage for memory and CPU, it's becoming slightly harder. We look for just all metrics within compute, it gets even harder. And then when we factor in compute, on-prem, public cloud, containers, every single parameter that we care about when we're managing our environment, we start from this kind of infinite set of states our environment could be in to a very infinitesimally small, tiny little window that's the desired state. That little teeny spot is exactly where Turbonomic is trying to keep us in 24/7. Now it's hard enough because we as humans can't calculate the millions and millions of different things we need to constantly keep us perfectly balanced, right, in that market equilibrium. But also, this target's always moving, right? It's moving based on the cyclical demands of our applications. It's moving sometimes based on anomalous increases in utilization. So we need a software with AI principles that's able to find that perfect little zone and then keep us in that zone 24/7. That is the exact problem that Turbonomic solves. That's something that a learning and monitoring tool can't do because it's not even trying to solve that challenge, right? So this is what you'll see when you open up Turbonomic for the first time. And I'll get into this a little bit deeper, but on the left is what we call our supply chain, right? Our supply chain is effectively a bird's eye view of our environment, right? Now, Turbonomic can be offered both via SaaS or an on-premise deployment. In order to get our supply chain, that's the first step. All we need to do is simply target what you want us to look at via API calls. Super simple. You tell us what you want us to see, your on-prem environment, your cloud environment, your applications, your Kubernetes clusters, whatever it may be. We establish a live API connection, we pull all of that data, and we stitch together that supply chain for you. You don't have to input anything other than the credentials to get us the read-only visibility to see those environments. Now, we're drawing the interdependencies as well, right? So the arrows that you see here, again, this represents a market, right? A market of consumers of resources and providers of resources. Your containers are consuming resources from your underlying nodes. On-prem, your VMs are consuming resources from your hosts and your data stores. We need to understand that supply and demand relationship in order to find that perfect market equilibrium. Once we create your supply chain, the goal is now to get your supply chain green, right? Green is good. Red means that we have some performance challenges. Yellow typically means that there's some inefficiencies or some cost waste. So what we do is we're generating actions for you. Again, you don't have to input anything to get this data. The actions are effectively saying, here are the steps that I need to take in order to drive my supply chain fully green, i.e. I am now in my perfect desired state. And then, of course, you can see the outcome of those actions. If we were, in this case, to implement every single one of these decisions, we have tens of thousands of dollars of monthly savings, and we have very, very few investments required to get rid of that red. Now, let me double click a little bit on the supply chain just to make sure it's clear. So I think of this as a three-step process. The first is abstraction, right? We need to abstract out your environment and create that supply chain to understand the relationships. Then we pull all of the analytics that we need, so historical data, capacities, utilization, basically understanding the demand profile of every single entity in your environment. Once we have that, now the system is generating actions. It's looking for opportunity cost, right, to kind of keep on that economic terminology. If there's a better place that our environment can be in, whether something needs more resources, something needs fewer resources, something can be moved, something can be suspended, maybe we need to scale up, scale out, that is what's driving these actions. And you can see we have actions at every single level of the stack, from the application all the way down through our container clusters, down into our infrastructure, whether it's private or public cloud. Effectively, we're creating full stack awareness. We know that if we take a decision up here, it's not going to hurt something down here and vice versa, because we know the relationship. We know the outcome of that action even before we take it. This is the first step, the supply chain. Moving forward. Now, we can show you tens of thousands of actions and say, yeah, they're trustworthy, just take it. But honestly, don't take our word for it. Every single decision, we have what we call the prove it UI, which is showing a number of things, right? In this example, we have a storage volume that needs more IOPS. It's a performance decision due to IOPS congestion. And as you can see here, it's actually yielding a savings. So this is a really unique example where we can get more performance, more IOPS, right? And you can see here over time, the utilization has been pegged at 100%. So this is obvious that this thing needs more, but it's also going to put a couple of dollars in your pocket as well. Now, on top of that, this is a fully non-disruptive and fully reversible decision, and it's fully executable right from the UI, and even better, if you had an automation policy in place, this would have been taken automatically without you even necessarily knowing that it needed to happen. So really, it reframes the conversation from, well, why would I take this action, to why wouldn't I take this action, right? And these are the questions that our customers are asking themselves, because Turbo makes it so simple to say, look, here's an opportunity cost, right? Maybe you don't necessarily feel the pain on this application right now, but if we want this to be in an equilibrium, it needs more resources, and you're gonna save some money. And we make it extremely easy for it to be implemented. Every single decision in our product has this prove it UI behind it. And that's really how we get to that level of trustworthiness. Now, I want to touch on a concept really quickly around automation. You've probably seen the word automation at every single booth thus far. You're probably going to hear it 1,000 more times over the next few days. I think there's a key distinction between decision automation and process automation. Process automation is easy, right? It's been done for decades. If X, then Y. If I hit 90%, automate an alert to my inbox. If I hit 85%, automatically scale me up by 25% of the capacity. It's a human-defined process, right? It's a script. It's something very simple to do. What's really, really hard to do, though, is decision automation, which is I, as a human being, am never going to calculate that infinitesimally small desired state that's always moving. But what I can do is I can automate whatever the decision is that comes out of Turbo that knows how to get me closer to that state. So I have no idea what the action is going to be or when the action will be generated. But what I can do is I can implement a policy that says on this scope of workloads for this action type, automatically execute it either live or during a scheduled window. Oh, and by the way, if I need to, let me tie into my CI/CD pipeline so the next time something's redeployed, it doesn't revert back to its original size, right? This is how we institute trustworthy automation at scale, right? And if you can't execute the decision, and if you can't lean on automation, then you're never going to be able to prevent risk. Again, can't prevent risk, can't assure performance, can't capitalize on savings. So really, automation for us is not a nice to have, it's critical. And it's really a key lever for us to truly be that preventative solution. Now, I want to talk a little bit about Turbonomic in cloud-native Kubernetes environments. And I think this is always a funny comic that we put up on our slideshows. But this concept of self-healing, I think, is really important because self-healing is not self-optimizing, right? If we're self-healing, we're admitting that we're actually getting sick. We're waiting to get sick, right? But what if we could have prevented ourselves from getting sick to begin with, right? Why are we waiting for containers to be automatically redeployed once they run out of resources. Because that period upon redeployment, sure, it's done automatically within Kubernetes, it's self-healing, but it's still a disruptive process. And what if that's happening dozens or hundreds of times throughout the week in our environment? We're willingly suffering ourselves getting sick. What if we could have automatically right-sized that container based on that supply and demand principle so it didn't run out of resources? What if we could right-size our requests? What if we could right-size our limits? What if we could factor in things like CPU throttling and know when the actual performance hits are about to occur to then automatically size resources to prevent us from ever needing to get healthy to begin with because we never got sick in the first place? That's how we work in Kubernetes environments. And it's a huge, huge, huge differentiator for us right now. Now, what that looks like in the product, again, very similar. Same type of dashboard, except now we're scoped to a Kubernetes cluster. As you can see on the left, the supply chain is scoped. And now you can see specific decisions related to this particular container environment. So like I said, sizing up due to VMem limit or request congestion, avoiding things like CPU throttling, and showing the capacity and usage on the bottom left of whatever namespace or cluster, or whatever it may be that we're looking at. And then even further, we do have an integration actually into another product that Turbonomic acquired a few years back called KubeCost, where we can push our recommendations into the KubeCost interface and actually understand the unit cost economics behind that decision, right? So if I were to resize this, how does it actually yield an additional savings? And kind of putting it into FinOps principles of every action having a measurable, quantifiable business decision behind it and business savings or costs associated with it. And here's just an example, I think a really simple one of node consolidation. So this is something that we were able to do for one of our customers in AKS without any right sizing at all. So again, by taking intelligent placement that's not waiting for alerts or for thresholds to be hit, that's preventatively keeping us in a more balanced equilibrium state, we're actually able to start decommissioning nodes, improving density, and saving significant, in this case, $15,000 a month just on a few nodes. And we see this across almost our entire customer base when it comes to optimizing container environments. Taking it one step further, what if we now bring in container right sizing? Well, sure, we're gonna get more savings because we're optimizing the containers on top of the nodes, but we're also solving what we call the ephemeral problem, right? If a container is alive for 2 minutes, 5 minutes, 10 seconds, how are you making historical, or how are you using historical data to understand how to size that container, right? There's just no data to go off of. Because we understand the unique ID of that additional replica being deployed, we can stitch together a historical baseline. So we might have a container that's redeployed 1,000 times for a couple minutes at a time, but we might have months of data to now make intelligent decisions on how to properly scale that container environment. Again, a huge, huge differentiator for us. Now, I only have a couple minutes left, and you probably have a lot of questions, and I encourage you to come by our booth and see a full demo from one of our turbo specialists. But I do want to just walk through a couple of proof points from what we've seen very recently with some of our customers. So this is one that I really love. It was an opportunity my team worked last year. Incredibly quick proof of value. 3 weeks, we targeted 70 AWS subscriptions. These guys took 3,000 actions during the POV, which is incredible. We do get customers taking a lot of action, but 3,000 is a ton during a POV. Things like scaling storage volumes, scaling databases, deleting unattached storage, scaling virtual machines, and they realized almost $500,000 in savings during a 3-week POV, which is absolutely incredible. There's a lot more for us to help them save across their sprawling environment, but this is just one of our most recent incredible proof points, and it's actually more common than you would think during a POV. And then one more, multinational professional services company, 6.6 million in cloud savings achieved. This one was in Azure, 45,000 VMs, over 12,000 databases, over 800 different subscriptions, executed 6.6 million realized savings with a total of 37 million identified, and we're still working at chipping away of more of that savings as we speak. So very, very quick time to value. To summarize, that's really what Turbonomic is all about, right? Time to value, quick ROI, quick payback period. We can only do that again. 1, we have to understand the performance needs. It's performance first. 2, we must identify waste and actually execute on those decisions. Alerts on a dashboard do nobody any good. We have to actually get to the point where we're taking and automating actions. Ultimately, we get 30% of our engineering time back, we have better performance, We have massively improved cloud investments. The list goes on. So, I would encourage you to continue the journey of Turbonomic by stopping by our booth, asking us questions. We'd be more than happy to give you a full demonstration. And then from there, right, take the Turbonomic challenge. Start a free trial, a free POV. Work with one of our teams to get it stood up for you. And let's see what cloud savings and performance improvements we can find with you today. Thank you so much. I appreciate your time.
Hey everyone, producer Andrew here. Thank you so much for watching and for your support. For more FinOps X 2025 content, go check out our YouTube channel. Like, subscribe, and leave comments and questions for all of our wonderful speakers. We appreciate your support.